Why hyperglycemic? Because it is to increase the blood glucose level. That's why it is called hyperglycemic hormone. It reduces, another point you can add here, under glucagon, cellular glucose uptake. Cellular glucose uptake. It reduces cellular glucose uptake. Which one? The glucagon. Utilization. Now coming to the insulin now. Is it clear about the glucagon? Secreted from the alpha cell is role. Actually, the facilitates the conversion of amino acid to lactic acid into what is called this process is called neoglucogenesis. Remember this thing. Or gluconeogenesis. Or same thing, gluconeogenesis. Neoglucogenesis or gluconeogenesis. Is it clear up to this? Whenever the process of formation of glucose from non-carbohydrate compound is called neoglucogenesis. This is the process of formation of glucose from non-carbohydrate compound. You can write here like this. Suppose non-carbohydrates glucose is formed and the process is called gluconeogenesis. Remember this thing. So remember this thing, glucagon facilitates conversion of this is accelerates gluconeogenesis. Remember this thing. Stimulates. That is glucagon stimulates neoglucogenesis. Stimulates, right? Stimulates conversion of. Glucagon stimulates, write better to stimulates conversion of. So I have to rub it out, please. Is it noted down? Is it noted down? Completed? Is it completed? Can I rub it out, please? Please respond.
Yes, sir.
Okay. Now, then comes to the beta cell secretes insulin. Just a minute, please. Insulin. So what is the role of insulin here? You see, first of all, by point 1, stimulating glycogenesis. Conversion of into glucose. Sorry. Glucose into glycogen. Fasting promotes oxidation of glucose. Stimulate transport of glucose from blood to the muscles and adipose tissue. And adipose tissue. Stimulates transport of glucose from blood to muscles and adipose tissue. Next one, inhibiting. By inhibiting, lower blood glucose levels by stimulating, by promoting, by stimulating. Look one thing. So complete it. Stimulating, by promoting, again by stimulating, again by inhibiting. Inhibiting glycogenolysis and gluconeogenesis. Next, promoting synthesis of fats from glucose and inhibiting the synthesis of fat and inhibiting breakdown of fat. Is it clear? Next, and by enhancing cellular glucose uptake and utilization. So this is how insulin is to maintain blood glucose level. Its role is to lower the blood glucose level by following way. And the another thing actually is when normal blood glucose level is normal blood glucose level is 80 to 120 milligram per 100 ml of blood. And if it is more than that, then it is called the hypoglycemia. Less than that, decreased blood glucose level called hypoglycemia. As it helps in decreasing blood glucose level, so it is called hypoglycemic hormone. As it increases cellular glucose uptake and utilization, so it is called hyperglycemia. You know, insulin is considered as hypoglycemic hormone. I think you need to remember here when blood glucose level one 80 milligram per 100 ml of blood, it is called glycosuria. You need to remember this thing. In glycosuria, glucose is found in urine. In glycosuria, glucose is found in urine. Remember this thing. Now, prolonged hypoglycemia. So can I grab it out, please? This part. Prolonged hyperglycemia leads to a complex disorder called diabetes mellitus. It's a disease. That's why they are to be given sometimes insulin treatment also. So this is what about what is called the insulin hormone. Is it clear?
স্যার উপরে চার্ট দেখা যাচ্ছে না।
কোনটা উপরেটা না? Clear? Now coming to the next, the delta cell. Can I rub it out, please? Complete it. Clear? Can I rub it out, please? Prolonged hyperglycemia leads to diabetes mellitus. And the symptoms of diabetes, the high blood glucose level, glycosides also may be a symptom. Is it clear up to this? Is it clear?
Yes, sir.
Okay. Now, next one. Delta cell of islets of Langerhans. It secretes somatostatin. It inhibits insulin and glucagon. Clear? Actually, whenever insulin is hyperactive, then somatostatin is secreted actually. So this is what about the islets of Langerhans and is now coming to the adrenal gland. Next gland is adrenal gland. Is located the anterior part of the kidney. Adrenal cortex and adrenal medulla. If it is a gland, this is the adrenal cortex. adrenal medulla. Now, in the adrenal cortex, from periphery to central layers are in the adrenal cortex. From periphery to center, the layers are Juna glomerulosa, fasciculata, reticularis. Three layers are there. Juna glomerulosa, Juna fasciculata, and Juna reticularis. From periphery to center, you will get these layers. Now, from these aldosterone, that is mineralocorticoids, are secreted. Remember these things. From fasciculata, glucocorticoids secreted. Gonadocorticoids secreted. So from Juna glomerulosa, aldosterone is secreted. From the Juna fasciculata, glucocorticoid is secreted. And from Juna reticularis, what is secreted? The sex steroid is secreted. Now, the role. Remember this thing. Now I have to rub this part, please. Basically, here the main, if you understand main ligand, right? Because the hormone is mineralocorticoid. That means Juna glomerulosa mineralocorticoid it is mainly aldosterone and deoxycorticosterone. These two are secreted from Juna glomerulosa. After that, the role of aldosterone. First of all, controls electrolyte and water metabolism. Electrolyte and water metabolism, the most important function of which. Secondly, Another most important function it has in the একটু মুছে দিয়ে যাবে যে জায়গাটা একটু না মুছলে হচ্ছে না রাখলাম এটা রাখলাম জায়গাটা মুছে দিয়ে aldosterone. How it controls? It stimulates by stimulating reabsorption of and excretion of potassium ion and phosphorus ions. By stimulating reabsorption of and excretion of potassium ion and phosphate ions. So it controls electrolyte and water metabolism by stimulating reabsorption of sodium ion and water from nephric filtrate and excretion of potassium ion and phosphorus and phosphate ions. Next one is the Juna fasciculator secreting glucocorticoid. And they are mainly called corticoids. Corticoids involved in corticoids involved in are called glucocorticoids. The main body is, remember this thing, is cortisol. Remember this thing. Actually, you better write glucocorticoid. Corticoid involved in, so you like not corticoid, good. Actually, hormones secreted from adrenal cortex together called corticoids. Hormones secreted from adrenal cortex called corticoids. Corticoids involved in carbohydrate metabolism called glucocorticoid. Corticoids involved in maintaining ionic and water balance called corticoids involved in Ionic and hello, হ্যাঁ বলো। না আমি ক্লাস করছি। হ্যাঁ বলো। একটু পরে বলবো। হুম 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 হুম। So corticosteroids involved in maintaining ionic and water balance in the body. In regulating water and electrolyte balance are called mineralocorticoid. So remember this thing. Now, so this is what about the basic function of which already discussed here. Remember cortisol, actually cardiovascular activity, kidney functions are controlled by the cortisols. The basic function I am telling you here regarding the corticoids, I have to rub it out. Stimulates. What it is going to stimulate? Gluconeogenesis, lipolysis, proteolysis. Gluconeogenesis, lipolysis, and proteolysis. Cellular uptake, aminoacids, and inflation of amino acids. Cortisol inhibits cellular uptake and utilization of amino acids. Suppresses the immune response. Cortisol inhibits cellular uptake and utilization of amino acids. It also suppresses the immune response. Clear? It also stimulates RBC production. Cortisol inhibits cellular uptake and infiltration of amino acids. It also suppresses the immune response and it also stimulates the RBC production. So you need to remember from cortisols, the main glucocorticoid present in our body. Another most important thing you need to remember, hyposecretion of. Can I rub it out, please? So one thing, adrenal virilism. You need to understand these things. Okay. Is it clear after this? Okay. So gonadocorticoid is another, actually, the sex steroids, another gland is here, another hormone is secreted. This is mainly secreting estrogen, androgens, and progesterones from the body. So I'm telling you a few line about it. Gonadocorticoids, I have to rub it out. Adrenal cortex, junior reticularis, junior reticular secrete sex steroids. Role of which is to facilitates development of secondary sexual characteristics So remember this thing, this is the main function. Particularly in male. So this is what about the adrenal cortex. Now from adrenal medulla, two hormones are secreted. One is adrenaline, other is the noradrenaline. Noradrenaline. একটু দাঁড়া। দেখ, তাহলে এড্রিনালিন আর নর এড্রিনালিন, এখানে একটা বলি, ওরা ডিজিজ সম্পর্কে তোমাদের একটু জানতে হবে, আগের তরফ থেকে একটু বলি। Under production of adrenal cortex, under production of hormones by adrenal cortex, Addison's disease. That is deficiency of and mineralocorticoid. The other one is Cushing syndrome. It is caused due to excess secretion of cortisol. So you need to remember these two. In case of Addison's disease, if it is in Addison's disease, obviously, rise in sodium actually blood plasma level, sodium plasma level. So in case of Addison's disease, symptoms and decrease level and fall in plasma potassium level.
नीचे जा रहा है अच्छा
rise in plasma sodium level and fall in plasma potassium level, rise in blood volume, high BP, high blood sugar, all the other symptoms of Addison's disease. Clear? Is it clear? So this is what about the, the symptoms of Addison's disease. In case of actually Cushing syndrome, in Cushing syndrome, basically, actually this is the symptoms of Addison's disease, symptoms of Cushing syndrome, please, not Addison's disease. These are symptoms of Cushing syndrome. Cushing syndrome symptoms here. Now, regarding Addison's disease, because these symptoms of Cushing syndrome only. Now, symptoms of Addison's disease. Look, now coming to the symptoms of Addison's disease, low blood sugar, low plasma sodium level, vomiting, nausea, are the symptoms of it. So this is the symptoms of Addison's disease. These are the symptoms of Cushing syndrome. Now coming to the adrenal medulla now. Where is the Adrenaline or epinephrine? Norepinephrine. Both these hormones.
सर एक टू पढ़ दिए.
Huh? Oh. Both these hormones are secreted in response to stress. During emergency situation. During emergency situation. Hence, are called stress hormones. These hormones, hence these hormones are called, emergency hormones. Emergency hormones. The basic function, also called hormones of fight and flight, or flight and fight. Now the function, basic function, actually I am telling you here. I will rub the lower part again. Let me put it. Okay. Now coming to the functions. One, increase alertness. Piloerection. Wheezing of hair. Sweating. Heartbeat. Increase heartbeat. Increase the rate of respiration. Piloerection, sweating, increase heartbeat, increase the rate of respiration, and that's the basic thing. Now remember this thing: adrenaline, noradrenaline, dopamine. Together called catecholamines. They stimulate breakdown of glycogen to form glucose. They also stimulate breakdown of lipid and protein. So this is what about the adrenal medulla. You know this thing, ACTH is going to stimulate adrenal cortex, not the adrenal medulla. ACTH is going to stimulate adrenal cortex, not the adrenal medulla. So this is what about the adrenal hormones. Clear? After that, a lot of hormones are there. I'm just giving some names here and you need to go through its function. So that I can discuss the actually mechanism of enzyme action at least a bit. Okay. Look one thing. I want to rub it out first. The gland is kidney. From kidney, erythropoietin is secreted. From kidney, erythropoietin is secreted. Helps in the RBC production. From testes, androgen secreted. From ovary, estrogen, progesterone, and basically relaxin is secreted at the time of parturition. So better you write estrogen and progesterone here. Then comes to the gastrointestinal glands. And the hormone secreted from is gastrin, secretin, cholecystokinin, gastric inhibitory peptide, gastric inhibitory peptide, enterocrinin, vasoactive intestinal peptide, villicainin, so gastrin, secretin, cholecystokinin, gastric inhibitory peptide, enterocrinin, vasoactive intestinal peptide are the hormones secreted from gastrointestinal glands. Now, regarding their role, in short, I am telling you, the role of gastrin is to stimulate the secretion of HCl and pepsinogen. Pepsinogen. Secretin stimulates secretion of water and bicarbonate ions. Bicarbonate ions. Cholecystokinin stimulates secretion of pancreatic enzymes and bile juice. Bile juice from gallbladder. From gallbladder. Pancreatic enzymes from pancreas. This is not there. As a cholecystokinin stimulates secretion of pancreatic juice from pancreas and bile juice from gallbladder. Gastric inhibitory peptide inhibits gastric secretion and motility. Enterocrinin stimulates crypt of liver cone to secrete Saccas entericus. Vasoactive inhibitory peptide dilates peripheral blood vessels. Vasoactive inhibitory peptide of intestine and inhibit gastric acid secretion. Glycinin accelerates movement of intestinal villi. So this is what about the hormones. And besides this, already testes, the role of estrogen is very clear. Ovary, you don't know it. The secondary sexual character is controlled by estrogen, progesterone to maintain pregnancy. And then, relaxin is actually not mentioned here, also secret ovary and to help in parturition. Now, from kidney, already erythropoietin I discussed, it is to help in erythropoiesis, the formation of blood cell, RBC actually. So this is about the different hormones. Is it clear to you all? Is it clear?
Yes, sir.
Okay. So now the next part, I'll wrap it out here. Now, first one, hormones bind to extracellular receptors. Other is hormone binds to intracellular receptors. Actually, first of all, the hormones are of following types. Hormones interact with membrane bound receptors. Hormones interact with membrane bound receptors. The one type, and the hormones interact with intracellular receptors. The hormone, they are the steroid hormones. Steroid hormones. And other one is iodothyronins. iodothyronins. Those who are intake the extracellular receptors, they include the peptide hormones, amino acid derivatives. Derivatives. Just a minute, please. Eduardo. The hormones interact to membrane-bound receptors. They are the peptide hormone and amino acid derivatives. And hormones interact with intercellular receptors of the steroid hormones and iodothyronins. Now you see, clear? Basically, the classification of hormone is most important. Hormones are of classified as, one is peptide, polypeptide, protein hormones, two steroid hormones, three iodothyronines, and four is the amino acid derivatives. At least one example of each type: insulin, glucagon, amino acid derivatives, epinephrine, and the other estrogen, cortisol, testosterone, estrogen, progesterone. So this is the classification. So you know, those who are peptide hormones and those who are amino acid derivatives, they interact with the extracellular receptors, and those who are with the steroid hormones and iodothyronines, they have to interact with the intracellular receptors. Are you getting me? Intracellular and extracellular receptors. Now, in case of extracellular receptor, I am just telling you the story now simply, quickly. In case of extracellular receptor, I am telling you, whenever the hormone binds to, listen carefully, hormone binds to the extracellular receptor, the hormone receptor complex is formed, which in turn stimulates G protein, and activated G protein stimulates a membrane-bound enzyme, actually activator called adenylate cyclase enzyme. Once adenylate cyclase is activated, it helps in the conversion of ATP to cyclic AMP. Now, next case, cyclic AMP acts as second messenger here, which is to stimulate different enzymes one after another and eventually responsible for physiological response. So this is what about the hormones which are interacting with the extracellular receptor, where a second messenger to be formed. Where the hormone which are to interact with the intracellular receptor, here hormone can directly enter the cell, binds to receptor, forming hormone receptor complex, which in turn enters the nucleus and will bind to the DNA. DNA is stimulated to undergo transcription to produce RNA. RNA comes out of the nucleus in the cytoplasm. In the cytoplasm, it binds to, the, what it is called, ribosome to help in the synthesis of proteins, and proteins are responsible for the physiological response. So in both the cases, the proteins are to produce, or in both the cases, actually, ultimately physiological response occurs. In case of the hormones with extracellular receptor, here a second messenger is to be found inside the cell, which is to act on behalf of the hormone. But such second messengers are not required to be formed in those steroid hormones and iodothyronines, because in these cases, actually, what happens here? In these cases, hormone can directly enter the cell, so no second messenger is required. Is it clear to you? Is it clear? Two diagrams are given to your book. You can go through it, very simple diagrams. So whenever hormone binds to receptor, what happens? Is it clear? Is it clear to everybody? Any question? Any question from anyone, please? Orpita, do you hear me? Anyone hearing me?
Yes, sir.
So why are you not responding? Is it okay?
Yes, sir. Okay.
Yes, sir.
Okay. So you can go through yourself now. As your time is running, actually I have to leave now. That's why I'm hardly complete this. Now, your syllabus is almost completed, but in the next Thursday also, there will be an online class. If you have any doubt, you can clear during Thursday class also. Okay?
Okay, sir.
Because as the exam is going on now, then it is easy. Actually, it is suitable for everyone to attend if it is an online class. That's why I'm arranging online class for these days, a few days now. Okay? Do you have any problem regarding this? Do you have any problem, please?
No,
No,
sir.
sir.
No,
Okay.
sir.
All the syllabus is almost completed. So if you have any doubt, you can clear out in my next class on Thursday, which is online actually, started from 8 a.m. Okay? Next online class will be started from 8 a.m. on Thursday. Okay? And if you have any doubt regarding this, you can contact me. You can write to me directly, or you can even call me. Okay? So that's all for today. Thank you very much.